This is a presentation for the San Joaquin Valley APCD rule changes for rules 4306 and 4320 and burner technologies to meet those requirements. Applicability is going to be in the Central Valley counties, up to the north to San Joaquin, and down to the south to parts of Kern County. These rules are going to apply to boilers, steam generators, and process heaters. Sizes are going to be greater than 5 million BTUs per hour. Approximately 1,273 units are affected in these counties. A date that we're going to mention a lot is May 1st, 2022, and that is the first deadline for these rules to have information submitted to the district. And another thing we want to note is that these are two separate rules, but the district is looking for compliance to both rules 4306 and 4320. In this presentation, we're going to review boiler Nox Formation, Nox Reduction Strategies, Nox Compliant Options, some low NOx burners and controls that are available, and looking to combine energy efficiency with low NOx upgrades to offset some of the inefficiencies that may occur due to lowering the NOx to meet these requirements. And in the end, we'll have a question and answer. So for NOx formation, boilers that have burners use combustion to produce heat to make hot water or steam. Naturally, NOx is a byproduct of this combustion. NOx is a pollutant contributing to ozone depletion, particulate matter, and acid rain. There are three types of NOx formation. Thermal NOx, which creates NOx when there's under high temperatures. Prompt NOx, which creates NOx in a fuel-rich environment. And fuel-bound NOx, where NOx is part of the fuel that you're burning. Thermal NOx is the largest contributor to the overall NOx that we see on our burner emissions. When looking at combustion itself, it's fuel and air plus ignition, and the ideal combustion that we have is CH4, oxygen, nitrogen, converting into CO2, water, free nitrogen, and free oxygen, and it gives off heat for us to use in our process. Under high temperatures of combustion, generally above 2600 degrees, thermal NOx is formed. Nitrogen and free oxygen plus this excessive heat is what produces the NOx that we measure. As seen in the chart on the right, thermal NOx is created exponentially with the increase in temperature. So for NOx reduction strategies, we've got two main ones. One is burner modifications or a new burner. For burner technology, NOx emissions down to 5 ppm is achievable. It's less expensive than exhaust treatment solutions like SCR. So for units that are less than 20 million BTU, it's generally cost effective to go the burner retrofit route. The drawback is that you will lose efficiency due to higher excess air levels on burners like this. The second option, which we will discuss in a future presentation, is SCR. It's selective catalytic reduction. It is added to the back end of your equipment and can reduce below 2.5 ppm. To date, it's been installed on units as small as 8 million BTU, but typically because of the cost, it's usually reserved for larger units. There's a higher initial cost, and there is additional maintenance that comes along with it that's in excess of what you would see with just burner technology. One of the benefits to this technology is that it has a smaller impact on efficiency. So in the future, we'll be talking about this in a workshop. For burner NOx reduction methods, one of the main ways and one of the earliest ways we've been doing this is with flue gas recirculation. It's been a technique used since the 90s to start lowering emissions back in the days. Currently, we alter fuel air ratios and excess air. We improve the fuel air distribution and mixing. This will improve flame distribution, reduce hotspots, and even options that have been used is stage combustion. Most designs are focused on lowering the flame temp. The way they do this is by adding excess air. As we can see in the chart here, as excess air percentage increases, our efficiency also decreases. So that's the relationship between excess air and overall efficiency. The challenge when designing a low NOx burner is lowering the flame temp without reducing efficiency and flame stability. FGR has been used. It has a lower impact on efficiency, but can increase fan horsepower. Low NOx burners, typically categorized as 30 ppm, can operate with or without FGR. We do have burners that can operate without FGR to get 30 ppm. You can maintain 3% excess air with good control and good turn down, 5-to-1, with good flame stability. Ultra low NOx burners, typically categorized 9 ppm to 5 ppm, are definitely going to use FGR and have different air-fuel ratios and staging. Some designs have higher excess air. It can range anywhere from 9 to 5%. They may have larger fan horsepowers, 15 to 50% more due to the increase in flue gas recirculation, or they may even have less turn down and while holding the same good flame stability. As always, we're continuing to advance the technology and we'll continue to do so. Many of the burners now can operate at 4% to 7% excess air. Some of the conventional designs that we use utilize higher FGR and lean mixture designs, like our lean premix, which uses gas nozzles and metal fiber, or our lean rapid mix that uses gas nozzles with mixing occurring in the furnace. There are new designs aimed at improving efficiency. Ideally, we're looking to lower excess air, lower FGR percentages, and decrease fan horsepower. One example of trying to do this is with stage combustion, where we have fuel and air combusted in rich and lean zones to be able to maximize our efficiency. SCR is a custom engineered design. It can be put on new or existing equipment. As mentioned before, it's typically for larger boilers, mainly because for larger boilers, the ultra low NOx burners are going to take a significant hit on efficiency. And a lot of times you need NOx reduction lower than what you can typically get with just burner technology. SCRs are a good application for non-standard fuels or process heaters. We're able to scrub the flue gases down to just about any level that we need to attain. We've currently developed for fire tube applications as well due to their low stack temperatures. So more information will be presented in the future in one of our workshops. So for a summary of our NOx compliance options, our first is working with what we have, trying to make modifications to an existing burner. This may be applicable if you're at 15 ppm trying to go to 9 ppm or from 9 to 5. It could be a mix of physical changes with the addition of FGR or control changes that give us better repeatability. The next option would be perhaps installing a new burner. So for users at 30, 15, or 9, 5 ppm could be an option to do with just burner technology. And lastly, which will be in a future workshop, is installing a new boiler. The third option would be installing a new boiler, which we'll review in a future workshop for options that we have there. New boilers versus new burners will depending on the age of the boiler and if more money would be put into an existing unit that could be at the end of its life. For options that we have our LNO series burners. These are designed for our integral front heads on Cleveland Brooks boilers, and they will get the highest combustion efficiency possible at 3% O2 and still maintain sub 5 ppm NOx. It's a patent-pending technology using premix fuel and air to deliver to the burner head and is discharged radially while anchoring on the ID of the furnace. The size ranges for these are 250 to 700 horsepower. They can be retrofitted on some existing units. They can be provided on new units. So really, it's something we want to take a look at and see if it's an application that works for you. Currently, this unit only fires on natural gas, but additional gaseous fuels are to come. Next, we have our ProFire SBR series burners. These are our jet-style burners that are made to fit on any boiler out there. These units utilize FGR and can get down to 5 ppm with no problem. They maximize efficiency by using parallel positioning as standard and give you equal heat transfer across your unit. They're designed with easy access to the air housing for internal components, and with us lowering the blower motor requirements and using smaller fan wheels, we're able to operate quieter than many others. This is lower maintenance than some of the other units that may use air filters, and it does not have any fragile pieces that could break during operation and costly to repair. Our ProFire NT series burner is our time-proven design that we've been using for 9 ppm applications. It's a lonox lance style hammerhead design that utilizes swirling air jet aerodynamics to get mixing so that we can achieve those levels. It's considered a low excess air burner and operates around 4 to 5% O2 to achieve the 9 ppm NOx and 50 ppm CO. This unit would utilize FGR, and what makes this an ideal burner for many is that it can burn both gas and oil. The turn down on this unit would be 5 to 1. And in looking at our jet burner series, the NTs, the burner family, can handle applications up to 92 million BTUs per hour. They can attain 5 to 1 turn down and achieve 9 or even 7 ppm NOx throughout the entire firing range. They're all considered low excess air burners and are all available with advanced Hawk PLC-based controls to be custom configured for any application. Last but not least is our MTH burner. This is our fiber mesh burner. It's considered a high excess air burner, operates in the range of 7.5 to 9% O2. This unit requires a filter element to make sure that the burner element doesn't get plugged, which could be a maintenance item. This unit can attain 9 ppm NOx and 50 ppm CO and will burn natural gas. One of the benefits to this burner is that it can operate on relatively low gas pressure where some of the others can't, and no FGR is required for operation. The turn down will be about 3 to 1. All of the burners we're talking about here are available with advanced burner controls. They are systems designed by Cleaver-Brooks specifically for the boiler and burners for seamless integration. All come standard with digital positioning feedback from actuators to get precise control, repeatability, and reliability. It includes programming as standard for O2 trim to maintain proper fuel to air ratios across the firing rate. They also incorporate flue gas recirculation to monitor FGR rate and trim FGR as necessary. As a note, there are some Cleaver-Brooks models that can be retrofitted to 7 ppm from 9 ppm with just a controls upgrade. It's something we definitely need to look into, so if you could see a RFM representative, we can get you more information. So why would we try and combine energy efficiency upgrades with NOx upgrades? The main purpose is to mitigate any efficiency losses due to the retrofit to meet those lower emissions. Energy savings that we could see by implementing energy efficiency device could see anywhere from 1 to 5% increase. If we're able to do this as a single project, it'll reduce your equipment downtime, and it'll be more cost effective for implementing energy efficiency upgrades than if we had done them separately. By adding this, you can also create a payback that may not otherwise exist. With the increased efficiency, you're going to be reducing your natural gas consumption and reducing greenhouse gas emissions. There are rebates and incentives that may be available for some of the energy efficiency upgrades available to you. For those who are trying to get every little bit out of their boilers, this may help them get a little bit more steam or heat out of their unit. And for those that already have energy efficient devices that may be older in age, it may be time to replace those units and bring them back to good working condition. So some of the recommendations that we'll be giving, we approach it from the aspect that every customer is different. Everybody's got a different situation. We can evaluate the site-specific conditions and propose customized options. When doing our evaluation, we look at costs for energy, operations, and can help walk through the 4320 fee compliance requirements. We can do competitive analysis to make sure that you're making the most of your investment. As a reminder, for some of the milestones that are going to be coming up, May 1st, 2022, Rules 4306 non-deferred units and Rule 4320, which applies to everyone, need to submit an emission control plan and an authority to construct detailing how they will be in compliance. December 31st, 2023, Rule 4306 non-deferred units and Rule 4320, everyone that's affected, need to come into compliance by this date. January 1st, 2025, for those choosing the fee method to comply with 4320, invoices will be issued for 2024 operations. May 1st, 2028, Rule 4306 deferred units will need to submit their emissions control plan and authority to construct. December 31st, 2029, Rule 4306 deferred units need to be in compliance. So we've taken a look at several burner technology solutions in order to meet these rule requirements. When navigating these new rule changes, each user is going to have options to evaluate to see what makes best sense for them. And we're here to help assist through that process, as we've been dealing with a lot of different customers on this. Some early adopters have the ability to defer compliance until December 31st, 2029. And regardless of the course of action, all users must have compliance plans submitted to the district by May 1st, 2022.